Okay, so hello everyone, welcome. Can you hear me?
Yes, we hear you.
Okay, thank you. I'll just be waiting 1 minute, then we'll start out this session.
Mijanur Rahman.
Yes, please.
Just I have one query that is it possible to download this recording to
No,
listen
so
at our leisure?
actually it's not possible for our privacy. Okay, so it's
Okay,
not possible.
okay,
So,
no problem, no problem.
but you can get the lifetime access, all of recorded video classes. You can get the lifetime
Okay,
access.
okay, thank you, thank you.
Okay, so we'll start today's session. So basically, today is our second number of class. Okay, and after completing the 3 hours live training program, then we talk about the problem solving class for the previous class. If you face any problem or any issue, then we talk about for 1 hour's problem solving part. Okay, so first of all, I try to explain for the 3 hours live training program, and then move to the 1 hour's problem solving part. Okay. So in the problem solving, you can simply share your screen and then show me your problem. Then I will try to explain about the solution. So let me share my screen. Okay, can you see my screen? Okay, so basically today's session I will discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat, Sentinel or Modis. So this type of satellite image, how we can easily filtering and displaying, and then how we can easily create the different types of satellite composite, and how we can easily apply the different types of band combination and visualize our satellite imagery, and how to export the satellite imagery. It can be Landsat, Sentinel, or Modis. And we also talk about the import, filter, reduce, clip, and display the raster data in Google Earth Engine. We also talk about the time series chart, how we can easily create the different types of temporal analysis. It can be NDVI, NWI, or other time series chart, how we can create. We also talk. And how to export any shapefile from Google Earth Engine. We also discuss about that. As well as we also discuss about that annual image composite, how we can easily create the annual image or monthly image composite using Google Earth Engine. We also try to discuss about that. So let's go ahead and discuss one by one all of topics. So let me open my slide. So we already know about that Earth Engine public data catalog. So basically, Google Earth Engine is a totally cloud-based platform, So that's why when you want to use the Google Earth Engine platform, we don't need to download any kinds of satellite imagery. We can easily access all of satellite imagery. It can be Landsat, Sentinel, MODIS, different types of terrain dataset, land cover dataset, atmospheric dataset. We can easily access from Google Earth Engine public data catalog. Okay, and this dataset is the daily updating. We can easily get all of update dataset from this data catalog, and we can also use it. So this is the link about that. So this is the Earth Engine public data catalog link. So anyone can easily visit this link and easily get all of that publicly available dataset. Or if you want, you can also simply go to the code editor. Here you can see this is the code editor. In this code editor, you can easily find out that browse data catalog, this option. Just click on here. Then it open this link. Here you can see this is the link about that, this same link. So in this link, we can easily get all of publicly available Google Earth Engine dataset. So here you can see it provides a lot of dataset. It can be different types of climate and weather data, such as surface temperature data, climate data. Also you can see atmospheric data, weather data, imagery. It can be Landsat, Sentinel, okay, or MODIS, or high resolution imagery for a specific region, geophysical data, terrain dataset, land cover dataset. You can see about the cropland dataset, other geophysical dataset. So it provides a lot of publicly available dataset, and all of dataset is the updating daily. So that's why from here we can easily get that update imagery or update dataset, and further we can also use it. Suppose you can simply click on the Landsat, so then we can get all of Landsat image collection. You can see the Landsat, Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5, MSS. So all of Landsat image collection we can easily access from the Landsat. Also click on the Sentinel, then we can get all of Sentinel image collection, or Sentinel-1 SAR data, also Sentinel-2 multispectral instrument imagery, also Sentinel-3, also Sentinel-5P. So all of Sentinel image collection we can easily access from here. Also for the MODIS, click on the MODIS. So now we can easily get all of MODIS satellite imagery or MODIS product. Okay, different types of MODIS product. It can be vegetation, land cover. You can see the sono or leaf area index dataset, surface radiation dataset, photosynthetic activity radiation dataset, land surface BRF daily dataset. So it provides lot of product we can easily get from the MODIS satellite imagery. So here you can see MODIS land surface temperature dataset. Okay, MODIS vegetation indices dataset. Okay, it provides a lot of dataset for the MODIS. Okay, so now how I can use this type of data? Suppose I want to use the Landsat. Suppose I need the Landsat for any specific boundary. Suppose for my city of Dhaka, I need the Landsat image for my Dhaka city in year of 2023 month of January or any specific time period. So how I can filter this collection? So here you can see the Landsat collection. So we find out that lot of Landsat collection, Landsat 9. So basically it's the different on the time. You can see for the time period. Also you can see about the time period for the Landsat 8, this time period for the Landsat 7. So different time period you can easily get. So all of image, when you filter, this is the same process. Okay, for Landsat 9, Landsat 8, Landsat 7, this is the same process. If you learn Landsat 8, this same process you can also apply for Landsat 9. This same process you can also apply for Landsat 7. Okay, so this filtering process is the same for any image collection, and this filtering is depend on some factor. Okay, so now you talk about this type of factor, then move to this class, move to the code editor again. So when you filter any kinds of image collection, basically this filtering, it's depend on some factor. One factor, it's your region of interest. Suppose which area or which boundary you need the imagery. Suppose I need the imagery for Dhaka city boundary or any specific boundary. So first of all, you need to filtering your image collection with your region of interest. Second factor, it's called the image metadata. Suppose you need only for this image, which image will be not more than 1% cloud cover. So this is the second factor for filtering the image properties. So we can choose any, we always try to get the low cloud cover imagery, because when you want to choose the low cloud cover, we can get the very neat and clean satellite imagery. Suppose this is my another factor. I need the satellite image which is less than 1% cloud cover. Yeah, please.
Yeah. This is like limiting our access to some imageries that have more than 1%
Yes.
cloud cover.
Yes. So
So,
basically,
if I need to accept 10%, for example,
yes.
can I do it by
Yes. It also possible. It also possible.
possible.
Yeah. Suppose some region you try to find out less than 1% cloud cover image is not available, such as coastal area or river bank. So this type of region we don't find the less than 1% image is not available. So then we have to increase the cloud person level. Then we choose 5% and then check how many images are available. We put the 10 and then check how much image is available. Okay. So it's depend on the region to region. Some region is the less than 1% is available, then we can easily use it. Or some region 1% is not available, then we just increase the value 5%, 10%, 50%, or 90%. Okay. So it's depend on the region. So I will show you the practically one by one. And then third factor, a specific time period. Suppose you need the image for year of 2017, month of January. You need the image year of 2017, suppose summer season or rainy season or in a specific time period, we can easily filter. So these three factors we simply apply and filter our image collection. It can be Landsat image collection, or it can be Sentinel image collection, or any other image collection. We are just applying the three factors. First factor is my region of interest, mainly where I need the image. So I need the image, suppose Dhaka city. And then how I need this image. Suppose I need this image less than 10% cloud cover, or less than 5% cloud cover, or less than 1% cloud cover. And then when you need this image, suppose I need the image year of 2017, month of January, year of 2017, month of or summer season, rainy season. So when you filter your image collection, then we simply apply these three factors and then filtering our image collection. So now let's check practical example. Suppose I want to work for Landsat collection, and Landsat 8, Landsat 9, Landsat 7 is the same process for filtering. Also Landsat 5, Landsat 4, Landsat 5 is the same process. So I show you that for Landsat 8, you also try for Landsat 9 and Landsat 7 and also other image collection is the same process for filtering and visualizing. Just click on here Landsat 8 and we can get this type of, you can see surface reflectance, another is the top of atmosphere or raw image. So basically surface reflectance, it used for making the land use land cover mapping, or also used for LST monitoring. Okay. And top of atmosphere, it also used for making the different types of indices such as NDVI, NDVI or other things. But this two image collection is the same process for filtering. Okay. Suppose I will show you that for surface reflectance, just click on the surface reflectance. So now we can easily get all of information for Landsat 8 collection to surface reflectance imagery. So here you can see this is the Landsat 8 availability time period. We can get the image from year of 2013 to 2024. This time period we can get it, our satellite imagery. And this is the dataset provider, USGS. And this is the Earth Engine snippet. This Earth Engine snippet, it also called as the unique ID of this dataset. Every image collection or every data set, we find out this type of unique ID. It's called the Earth Engine snippet. Okay. So every image collection, you can get this type of ID. It's called the Earth Engine snippet. And also you can see about the description about this data set. You can get all of bands. Basically, you can see SRB1, SRB2. So all of band we can easily get coastal aerosol or blue or near infrared or green. Okay, also red, near infrared, short wave infrared one. So all of them we can easily access from here. So now this is my image collection. This image.
Sorry,
yeah, please.
What about And 8, which is panchromatic.
Which one?
Band number 8, the panchromatic band, which
Yeah.
is
So
has,
panchromatic
high
band
resolution.
is available for top of atmospheric imagery. Yeah. So it's available for the top of atmospheric imagery. Suppose I'll show you that. Just I check it's a surface reflectance. When I just click on the top of atmosphere, in this top of atmosphere, we can get that. You can see the band 8 panchromatic band. Okay, so it's available for the top of atmosphere, but surface reflectance it's not available. So that's why when you want to reduce the pixel area or increase the resolution, then we have to use the top of atmospheric imagery because it's available for the band 8 or panchromatic band. Okay, so we talk about the surface reflectance. So this surface reflectance I have to filter. So now this is my image collection. This image collection I need to import in my code editor. Okay, so now how I can import? There is the two way. One way is that you can simply copy the ID. So this unique ID, simply copy. Just simply copy this unique ID. Copy and paste on your code editor. Just paste. So now here you can see we can get the ee.image collection. And then we can get that collection ID. This is the collection ID for Landsat 8 surface reflectance. Collection 2 satellite imagery. So this is the ID. I simply paste in here. Then you just give a name, give a variable name. So you already know about that how we can easily add the variable name. So before the variable name, just put the var keyword. Okay, and then you can put any name as a variable. As a variable, you can put any name. I put the name suppose L8, then equal sign. So now this is my full image collection. This image collection, I just store it in this variable. This variable name is L8. Okay. So now I want to check in this collection how much images are available for the whole world between this time period, year of 2013 to 2024. How much images are available in my collection? I want to check it. So for that, just use a function, print function, because I want to print my output, how much images are available in this collection. And this collection is stored in a variable. This variable name is the L8. So I call the L8 because it is stored. And I want to compute how much images are available in this collection. For computing this, just use here the size function. Okay. Size function computing the number, computing the size of image collection, how much images are available for the whole world between this time period, year of 2013 to 2024 for this Landsat 8 collection. It check. So now we try to run the code, click the run. We can see it show about the number computing, and now it computed how much images are available in the Landsat 8 collection and from year of 2013 to 2024 for the whole world. So now computing.
After size, I have to put these values also.
Which one?
You write print L8 and size, and then you open
Yeah. So when I define any function, we have to use this type of parenthesis, start and in parenthesis, we have to define. Okay. When we write any function. Okay, let me increase my screen size. So now I can see more better. Okay, so here you can see we can get that very more than 1 million images. It will enter the large number of image collection for the whole world. Okay, so it show the result for the whole world between the time period year of 2013 to 2024. But this image collection I want to filter. So how I can filter? We already know about the 3 factor. Basically, where you need this image, this is the 1 factor I use, and I filter the image collection. Suppose I need the less than 1%, so this is my another factor. Suppose I need the image for year of 2070. So this is my another factor. Just I apply the 3 factor, and then this large number of image collection, I simply filter. So now it show this image collection show for the whole world, but I don't need for the whole world. I need only for my study area. Suppose my study area is the Dhaka city or any other study boundary. So previous class we discussed about that, how we can easily importing our shape file in Google Earth Engine. Asset, we already discussed about that. So here I already import a shape file. I simply click on here and then simply import my shape file. Suppose I need, this is my study area. Suppose this is my study area. Okay, so this is my study area. I need this imagery for my study area. So here I already imported this shape file of Dhaka city boundary. So just I simply import. Okay, so now it imported. And its default variable name is the table. Okay, so you can put any name as a variable. We already know. Suppose I put the name, it's a RY, or you can put any name as a variable. Okay, so now this image for whole world, but I need this image only for my study area in Dhaka city. So for that, just take a variable. Suppose I put the variable name is that filter region. You can put any name as a variable. And then I call the L8 because this L8 is stored the large number of image collection. So I call the L8. Now I need this image for my study area of Dhaka city, which is stored in the ROI. So for that, for filtering this region, I simply use a function, this function called the filter bounds function. Okay, so this is the new function, filter bounds function. So basically this function intersecting the large number of image collection with your study area. And now if you want to just put the parenthesis and check the what is the argument, we get the argument is the geometry. Geometry mainly it's a boundary. Okay, so his boundary you won't need this image. So my boundary is the Dhaka city boundary. It is stored in the ROI. So just I put here as a ROI. Okay, so this L8 it is stored the large number of image collection. It's for the whole world, but I need this image for my specific boundary. So that's why I simply use the function filter bounds function and then define my study area ROI, because ROI is stored in my shapefile. Okay, so now let's check how many images are available, how much images are available in the Dhaka city boundary. I want to check it. So for that, just use here the print function and call the filter region, simply copy and then use the size function. So now it computing how much images are available only for Dhaka district boundary, which boundary I want to import in here. Here I find out that 459 images are available for the in the Dhaka city boundary between the time period year of 2013 to 2024. This time period we find out the total number of images 449 in Dhaka city's boundary we find out. Okay, so now suppose from here, from 449 images, I need only for those images which image is less than 1% cloud cover or less than 5% cloud cover or less than 10% cloud cover. I need only for the specific cloud level. Suppose I need the less than 1% cloud cover. So for that, just take the another variable. You can put any name as a variable. I put the name, suppose filter metadata, or you can put any name as a variable. So now from 449 images, this 449 images stored it in a variable. This variable name is the filter region. Simply copy this variable and paste here. And now I want to filter the image metadata. So for that, use the function filter metadata. So basically this function filtering the image metadata such as cloud cover label or land cloud cover. So this type of image properties filtering using the filter metadata. If you want to check what is the argument about that, we can easily get it. So here we can get that name, then operator and value. So what is the name? Name mainly image properties name. So you can easily get the image properties name. Here you can see in your image properties, we can easily get it from our, in here you can see the image properties. So here you find out that this type of image properties, I want to choose suppose cloud cover. Simply copy the cloud cover image properties name and further use this name in here. Okay, it's my cloud cover, it's my image properties name. Then set the operator. Suppose I want to use for less than, and then set the value. Suppose I need the less than 1% cloud cover, just put the 1. Now I want to check how much images are available in my Dhaka city which is less than 1% cloud cover. I want to check it. So for that, simply use here the print function and call the filter metadata. Simply copy this variable name and then use here the size function. So now it computing how much images are available in the Dhaka city which is less than 1% cloud cover. We find out that 65 images. This 65 images is the less than 1% cloud cover. And what is the duration? What is the time duration? Year of 2013 to 2024. This time duration, we find out that how much images is the less than 1% cloud cover. We find out the 65. If you want, you can also put here, suppose less than 10%. Just put it the 10. So now it computing how much image is available, which is the less than 10% cloud cover. We find out that 147. And what is the time duration? This time duration is the year of 2013 to 2024. This time period, we find out that 147 images is the less than 10% cloud cover. Okay, suppose I choose the less than 1%, we find out that 65. But some region such as coastal area or river bank, so this type of region, you don't find the less than 1%. You just put the 1, then you can get the 0. 0 means that for this study area, there is no image less than 1%. It means that. So then you just simply increase the cloud cover level, 1%, 2%, 3%, 4%, 5%, 10%, 20%, and then check how much images are available. Okay. So in this case, Dhaka city, we can easily find out that less than 1% image, we can easily get it. So now this duration is that year of 2013 to 2024. But I want to need the image, suppose year of 2023 or in a specific time period. So for that, just take the another variable. I put the variable name, suppose filter date. You can put any name as a variable. So now from 65, this 65 image is already stored in a variable. So you simply put this, call the variable name filter metadata because it is stored the 65 images. I just put in here. And then use that filter date function. Okay. So now we have to define our time period, start and end time period. We simply define in here. So for that, just put the times, suppose the year of 2023, 1st January from year of 2023, December, suppose 31. I choose the whole year of 2023. So now let's check how much images are available in year of 2023. Simply print again this variable name filter date, copy, and then use the size function to computing how much images are available. So we find out that 7 images are available in year of 2023, and this 7 images is the less than 1% cloud cover. And this 7 images is available in my study area of Dhaka city boundary. So when you filter your image collection, just we use this type of code. Suppose first one, where you need this image. So where you need this image, for the where we are just use here the filter bounds function. Then filter metadata, so it's called the how. Suppose I need the image less than 1% cloud cover, so it's called the how. And then second and finally filter date. So basically when you need this image for a specific time period, when you need this image. So basically where, how, and when, using this 3 factor, we can easily filtering the any large number of image collection. So first of all, here you can see when I check how much image is available for my study area, we find out that 449 images. When I check from 449 images, how much image is the less than 1%, we find out the 65 images is the less than 1% cloud cover. From 65 images, when I check how much image is available year of 2023, we find out only for the 7 images. So now I want to check all of properties for these 7 images. I want to check it. So for that, just simply use the print function and call this filter date this variable and then click run. So now we got all of properties for total 7 images. So here you can see it look like that. Let me open. Okay, we can get the 7 element. It means that it's total 7 images, okay, in this collection. And we can get all of images that here you can see. So we can get this type of images. So 0 is the first item we already know. So this is the 1 image, then 2, then 3, then 4, then 5, 6, and 7. So we can get all of images. Suppose I want to check these images and check all of properties for these images. You can see also you can say about the acquisition time, year of 2023, 18 January. So all of information you can easily get it from for every images. And also get all of images. You can see this image cloud cover is the 0.1. Okay, so all of things we can easily get for the every single image. We can easily get it. So now from here, suppose I want to use any single time period image. Suppose this image I want to use, which is the year of 2023, 11th November. So this image I want to visualize on my map, or I want to use this imagery. So how I can visualize the single date image? So for that, simply copy this ID. Simply copy this ID of your image. Simply copy. And further, take a variable. So it's called the single date image. So just take a variable. I put the variable name, suppose image, and then use the ee dot image, and then put this ID. Okay, which ID I copy from here. Just paste in here. And now further, just map dot add layer. So now we visualize this image. Click the run. So now it added the layer, but not focus my study area. For the focusing, we already know about that. We have to use the function map dot center object. Okay, and then I want to focus on my study area ROI. Zoom level suppose 10 and click run. So now I can see it added these tiles. We can get this type of tiles, and this tiles acquisition time is year of 2023, second 11. This time we can easily get this satellite imagery. So this satellite imagery, it look like that default color, but when I add the band combination, then it also more better. Suppose I just click on here, and further I set the band combination, suppose red. Suppose then put at that green, and put at the blue RGB color or natural color. Then I just stressing the data, suppose 98%, and further apply. So now we can got this type of imagery as a tiles. Okay, we can get this type of imagery as a tiles. But this tiles have a problem. This problem is that it not fully cover my study area. If I add my study area, Dhaka city boundary shape file. So further I simply add the another layer, suppose map dot add layer, and call the ROI. So now it also added my boundary shape file layer. We can get the 2 layers. One layer is for images, another layer is for our study area. So here you can see this is my study area, but some part is missing. So this part is not fully fill up these tiles. So for that, in this case, we are trying to add the another ID, another image. So we can get total 7 images in here, and we find out that this image is not fully fill up my study area. So that's why you try to check the another images, what's happened for that. Suppose just click on the picture and try to check, suppose I want to check it, this imagery, and simply copy this ID. Copy this ID, and further just change this ID from here. Okay, then click to run. So now let's check what happened for these tiles. Is it fully fill up or not? Okay, so in this case here you can see this tiles is fully fill up with my study area. So that's why I can easily use it for my study area, because in this case it fully fill up my study area. And what is the time period about that? Here you can see we got this time is that year of 2023, 0408. Okay, 8 April. We find out that this imagery is fully fill up my study area, so that's why I can easily use it. So now further, when it fill up your study area, then simply use the clip function, just clipping with your boundary. So just use here the dot clip function and then clip with your study area. So in this case, my study area is the Dhaka city. It is stored at ROI. So just put here the ROI. This is my shapefile variable name. So now click on run. So now here you can see we can get this imagery only for my boundary. Dhaka city boundary, you can get it look like that. So it's the default color, it look like that. But when I add the band combination, suppose this is my, click on here. And further we just try to add the suppose red, then green and blue. Just we set the stressing. Stressing is one kind of data visualization process. I put the 98%. If you want, you can also put the 90%. It's not problem. So it's different. Just I put the 98% and then stressing the data. And then we get this type of imagery here you can see. So this is our satellite imagery. Yeah.
I have one question.
Please.
Yeah. So the stretching that is, you see full stretch, 98% stretch, and so which one is appropriate? How we can decide to apply which
so basically,
stretch?
okay. So basically, some data set is work very well for the 98%. Some data set is the 90%. So for that, you have to check the sometimes suppose 90% or 98%, and we provide you the more better visualization. Then use it. Suppose when you want to make the rainfall map or other types of map, then we check the 90% or 3 sigma, this type of stressing provide with a more better result. So that's why it's not any kind of fixed, but for the satellite imagery in the 90% stressing, we can get the more better result. Okay, so it's not fixed. If you also suppose I put the suppose stressing 3 sigma and then check how we can get it, suppose applying. So now we can got this type of result here you can see. Okay.
Okay.
So it also not more better. We can it also good. There is no problem. Okay. You can see you can get more better visualization.
Sorry, yeah, I just missed that part where you found the image that covered the entire study area. Can you just show that part of the code again?
Yeah. So I will show you that because in this case we talk about the single data image. Further, we also talk about the image composite, how we can easily combine all of images. Suppose you need this satellite image for the whole country boundary of Bangladesh. Then one tiles is not enough for the whole country boundary of Bangladesh. Then we have to apply the image composite method. We can use the median or mosaic. Then it also fill up for the whole study area.
So in this case, you just looked for an image that covered the entire area.
Yeah.
I see.
Yes.
Okay, thank you.
Okay. So now, please.
Can you please give us information about the bands and about the Landsat and model?
Cannot hear you properly. Hello, please.
Can you please give us an introduction about the bands and the Sentinel, Landsat and models? Brief introduction, please.
For this?
Bands, about the bands.
Bands combination.
Yes.
Okay, so basically, so I'll do that, no problem. Okay, so basically now we can get this type of band combination. Here you can see red, green, and blue. So if you also try to search on the Google, suppose I simply search Landsat 8 band combination. So there we can get, okay, so this is the very, deeply describing here. This link we can easily get Landsat 8 band combination. So basically we are using here the band combination. When you want to use different types of band combination, then we can easily get extract the different types of object from satellite imagery, such as here you can see there are also provide some description about that. So so let me so here you can see different types of band combination. So basically natural color mainly what human eye can see naturally we can get the vegetation as a green color. naturally we can get, okay, it's a natural color. So it's called the natural color. So Landsat or Sentinel, both of images, when you apply red, green and blue, these three band, red, green and blue, then we can get the natural color. It's called the RGB color also. Basically, it's the naturally what human eye can see. Suppose healthy vegetation is green, unhealthy flora is the brown, urban feature appears white and gray, water is dark blue or black. Okay, so it's the natural color all time, red, green and blue. For Landsat or Sentinel, when you apply the red, green and blue, these three band and make the combination, then we can get the natural color all time. And in the natural color, we can get the healthy vegetation is the green, unhealthy flora is the brown, urban feature is the white. So in this case here you can see we can get this type of, you can see we can easily get it. It's a vegetation, green color. We can easily identify it's a urban or build up. Okay. Also you can see about that we can get this is the water body. So not only for that, I want to apply the another one. Suppose just click on here. I put the suppose near infrared, then put here that red and put the blue. Stressing suppose same as 98%. Then apply. So in this case, I can get the another types of visualization. So in this case, vegetation show as a red color. Okay, this type of red color identify about the vegetation, and water body show as a black color or dark color. Okay, we can easily identify for that this is the water body. You can see it's the water body, black color or dark color, and we can easily identify this type of red color is a vegetation. We can easily understand about that. We can also get this type of gray color is the barren land. We can easily get it. And it's the for universal for any region. When we apply this type of band combination, we can easily get the same visualization. Suppose here you can see the 543. Basically, this is the near infrared red and green. So when you apply the near infrared red green, then you can get this type of visualization. In this visualization, you can get the vegetation show as a red color, water body show as a black color. We can easily get it. Not only for that, you can also check the other. So you can see this is the short wave infrared 764, mainly short wave infrared 2, short wave infrared 1 and red band. When you apply, then we can get this type of visualization. And also you can see it's called the agriculture band combination. It's for short wave infrared 1, near infrared and blue. So then we can easily get it, this type of things. And using this band combination, we also extract the agricultural land. So when I talk about that land cover classification, then I also discuss more details about the band combination. So here you can see we can easily get it, this type of shape. When basically agricultural land, we can get this type of shape. Okay, a square shape or rectangle shape. But normal vegetation, there is not any kind of shape. It's the randomly distributed. But for the agricultural land or crop land, we can get that shape, rectangle shape. This type of then we can easily identify it's the agricultural land, and this is a vegetation. We can easily get. You can see this is a vegetation, and this is the agricultural land. Because agricultural land have a pattern, we can get the rectangle shape. Okay. Also, you can see when you identify any kind of geological, we can easily get it. Band combination for useful for identifying the geological formation, lithology feature and faults. Also bathymetric, when you want to do it, just simply apply this band combination. Then we can easily identify for that bathymetric feature or aerosol studies. It's very helpful. Okay. So there's a lot of band combination. We also use it. So you also try to check this link. I also attach the link in our Google Classroom. Then you can easily get that idea how it will work, this type of band combination. And it's very useful to make the land use land cover mapping or object detection from the surface. Okay. As well as we also use here the band ratio. So band ratio is one kind of band visualization, image visualization process. Using the band ratio, we can easily detect the different types of mineral from the satellite imagery. So you can easily get a lot of information. Okay. So this is the process. Suppose this is the, I just apply this band combination, look like that. So now this visualization, I want to import in my code editor. So for that, simply click on the import button. Just click on the import. Okay. When I click on the import, a new line of code will be added in my code editor. Here you can see this code editor is it's added the new line. Okay, it's added. Simply copy this name, and further I want to add after my layer name. So this is my image. I want to set the color. So just put this visual parameter, this variable name. I just put in here. So we already know in the previous class, first of all object, then image visualization parameter. So in this case, this visualization I want to set, and this visualization is stored in this variable. Okay, so which I imported from here, and further I put the name. Suppose I put this name is that false color. Okay, now click the run. So now this color is set with my map. You can see it's set it with my land use Land Rover satellite image. It's set it. So I want to set the another band combination. Suppose just click on here again, and further I will set suppose natural color. For the natural color, red. Then put here the green and blue. Stressing suppose 98%, and further just apply it. So now you can see this color. It's also added. I want to import, so just click on the import button again. So now a new line of code will be added in here. You can see this, it's added. So now these things I want to add as a layer. So for that, again, write the code. Just I simply copy the same code, simply copy and paste, and then I call this variable name and put the layer name. Suppose it's a natural color. Click the run. So now we can got these two layers. One layer is show for the false color, another is show about the natural color. We easily get the two layer. We can easily add in here. So you can see we can easily add. Suppose you want to add the more other band combination for that. So simply click on here again. Suppose I want to add for that shortwave infrared one band. Then put here near infrared band and blue. Then simply stress in 98%. And then further just click on the apply. So now it's set this type of visualization. Okay, and now I want to import it. So simply click on the import. You can see a new line of code will be added in my code editor. A new line is added in here. So now further I want to visualize it. I want to add the layer. Same process. Simply copy this visualization. Simply copy. And then further add the layer. Just change the variable name. And I put this, it's a, suppose I put the name as a agriculture. Okay, so now we can, it also set it with our band combination. So we can easily add the different types of layer for the using the different types of band combination in here. Okay, and first one is our study area or your boundary layer. So this is the image. So further I also show you that how we can easily export this type of satellite imagery from here and also use for ArcMap or QGIS software. We'll also discuss about that later. So it's the single date images, okay, for the small study area. But when you want to work for the big study area, suppose you want to work for whole country boundary of Bangladesh, you need the satellite imagery. Then one tiles is not enough. Suppose I need the imagery for my whole country boundary of Bangladesh. Okay, so then one tiles is not enough, because if you want to search on the Google, suppose I simply search Bangladesh satellite tiles. Okay, just a minute. Okay, Rohan for Landsat. So here you can see for this Bangladesh. Okay, let me open. Yeah. Also. So here you can see when fully covered. Suppose for whole country boundary of Bangladesh, when you want to need this satellite imagery, this type of composite you need to create, then one tiles is not enough. One tiles is not enough for that. For that we need, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Total 14 tiles we need to use for covering the big study area. Okay. So for that we need to use the image composite. So we can use the different types of image composite. Suppose all of tiles, all of images, we simply make the composite. It can be median composite or mosaicing. Okay, so this type of things we are applying and then we can easily make the satellite imagery for the whole country boundary of Bangladesh. So let's go, I'll show you an example how we can easily create for the whole country boundary of Bangladesh, because one tiles is not enough. Suppose this type of single date imagery is not enough for the whole big study area. Okay, but a small study area we can easily choose for this one tiles, and then we can check it, is it fully covered or not. But when you work for the big study area, which study area have one tiles is not enough, then we just applying the image composite method, and then we can easily create the composite. So in this case, okay, so let me import the study area. Suppose whole country boundary of Bangladesh, I simply import, and then just give a name, variable name. I put the variable name, suppose BD. Okay, this BD stored my shapefile boundary for whole country boundary of Bangladesh, and now I want to need this image for the whole country boundary Bangladesh. Okay, so for that I simply change it in here. Okay, just I put here BD. Okay, because BD is stored the full country boundary of Bangladesh. Okay, and now I want to choose, suppose less than 1% imagery for the BD, and then I need the image for year of 2023. Okay, so now finally we check how much image is available. So just click to run. Now it's computing how much images is available for the whole country boundary Bangladesh, and this image is the less than 1%. How much image is the less than 1%, and it's available in year of 2023. So here you can see that we find out the total 71 images. Okay, this result 71 images for the full country boundary of Bangladesh. Okay, in year of 2023, and this 71 image is less than 1% cloud cover. So now I want to use this all of images, total 71 images, and then create the median composite. Okay, then it fully fill up my full study area. Otherwise, if I try for single imagery, if I try for this type of 71 single imagery, suppose I simply click on here and copy this ID. So then this type of single imagery is not fully fill up my study area. Okay, so that's why I need to create the median composite using total 71 images and create this composite. So let's go ahead and discuss about that, how we can easily create that. So I write the code in here. Suppose I just write the code in here, say median composite. Okay, it's neat when you want to work for the big study area. So for that, just take a variable. Suppose I put the variable name is that final image, and I call the 71 images. So here you can see this variable filter date. This variable is stored the 71 images. In this case, I want to use total 71 images and create the median composite. So I simply copy the 71 images and then paste here, and then use the function median. So this function calculate all of images middle pixel value and create this composite. Okay, so now if I just map.add layer of my final image. So just okay, let me check after some time. I simply copy and final image and then click to the run. So now you can see here. Okay, we have to use the function. We have to use the parenthesis, otherwise it will not work. So click to the run again. So now all of total 71 images create this composite, and which fully covered the whole study area of Bangladesh. Okay, so here you can see it create this type of composite. Okay, and this composite is created using by total 71 images. So you can see now Bangladesh boundary is the fully fill up. Okay, now Bangladesh boundary is the fully fill up. It look like that because I don't use the clip function. So now further I can simply use the clip function. So after the median, just put here the dot clip with my study area BD, because BD is stored in my shapefile. So now click to the run. So now it's just clipping with my boundary, and now I got this image only for my Bangladesh boundary. So now here again we can get this type of imagery for the whole country boundary of Bangladesh. Okay. So now further, if you want, you can also add here the band combination. Just click on here, and then you can easily set the different types of band combinations. Suppose I will set red, then green, and suppose blue, RGB color, and then stressing 98%. So now we can easily get the natural color band combination for this static area. With loading, and further just apply. So now we can easily get that natural color pen combination for this whole country boundary of Bangladesh. So we can got this type of imagery. Okay, and this imagery created from total 71 images middle pixel value. Okay, it's not for any single date imagery. It's the total year of 2023. All of images, less than 1%, all of images create this composite. So now further you can easily use this image and make the NDVI map, NDVI map, or any other remotely sense analysis, or land use land cover map, or anything. We can easily do it for the whole country boundary of Bangladesh. Or if you can easily set the other band combination. Suppose I put here the near infrared, then put here that red and blue, stressing at 8%, and further just apply. So now it will set it. We can easily get that false color composite, false color image band combination. Or we can get this type of image collection.
I have one question.
Yeah, please.
Yeah, these images are for the whole year.
Yes.
So if we can use this for NDVI, so the NDVI, how we can say that this NDVI is for January, February,
so
March,
this
or December?
Okay, so if I create this imagery and make the NDVI, then we can say that it's the NDVI for year of 2023. Okay, because in this time we considered the whole year, all of images less than 1%. Okay, or we can say that it's the average NDVI, because when I calculate, suppose we can say that it's the average NDVI in year of 2023, all of images for in 2023 less than 1%, all of images we considered, and create this composite. Then we make this NDVI.
So we cannot discriminate that which area is for April and which area is for May, or like that?
No, in this case we consider all of images, because total in year of 2023 it captured the total 71 images for the different time. Okay. It captured the imagery. So in this case we just combine all of images. We take the whole year, all of images. But further, when I discuss about the annual image collection or monthly image collection, then it also possible for the monthly. Suppose we can easily calculate the monthly NDVI. Suppose January, February, March, all of monthly NDVI, it also possible. Or monthly composite, it also possible. But in this time, it show about that 1 year, basically 1 year, 2023, all of images composite.
Okay.
Is it possible to know the method data of this composite? I mean, the dates of the images that used to create this composite.
Yes. So you can easily get the date from here. Here you can see it also show you all of information, all of total 71 images date. We can easily get it from here. 71 element means the total 71 images, and just click on feature, so we can easily get it. So here you can see the year of 2023, 20 January, then 5th February, So all of date is also including in here. 21 February, 10 April, 19 October. So all of
I
date.
mean, these are the 71, but of course, when the code create the composite, choose a specific from these 71. Can I know which images that selected and
No.
which
So in this case, this composite is created from total 71 images. Okay. So all of images including in this composite. So all of images, total 71 images we consider, and total 71 images middle pixel value create this composite. Okay. Suppose all of images. Suppose this it's a single image. So this image is a single image, but this single image is created from total 71 images middle pixel value. Every images provide the middle pixel value and create this median composite. Okay. So in this case, it create from the total 71 images middle pixel value and create this composite.
Okay, so the average, for example,
yes.
the digit number of each pixel, they took the average from the 71.
Yes. So basically, when you use the median, then we can get the more better image visualization. If you want, you can also take the average. Suppose just put here the mean. Then total all of images average pixel create this composite. When I put here the mean. Okay, as well as we are also using the suppose minimum. Okay, so then all of images minimum pixel create this composite. If you want, you can also put here the maximum. Suppose put here the max. Then all of images maximum pixel value create this composite. And when I put here the median, then all of images middle pixel value create this composite, and we can get it. Okay, from total 71 images, all of middle pixel value create this composite. And when I use the median, then we can get the more better imagery than minimum, maximum, or average. Okay, we can get the more better image visualization when you take the middle pixel value, all of images, and create this composite. Then we can get the more better imagery. Okay, so then further we can also use this imagery for creating for the different types of remotely sensed work. And when you work for the small study area, then you can easily take the single data image. We can easily get it from here, and further we can easily work for that. But it's neat when you want to work for the big study area. Which study area one tiles is not enough. Suppose for Bangladesh, we find out that total 15 tiles is neat for covering the whole country boundary of Bangladesh. So that's why you can easily create the median composite and create this type of composite and work with that. Not only for the median, further next class we'll also discuss about the mosaic, how we can easily create the mosaic composite. Also discuss about that also. Okay. So this is the process to filtering and also visualizing the single data image and median composite image. So in this case here you can see I write the code look like this way. So I take the filter bounds function, I take the new variable, also just take the filter metadata function, also take the new variable, also take the filter date function, and also put the new variable. So every new function I take the new variable, individual variable I take. But if you want, you can just take only for the one variable, and under this variable we can put all of function one by one. So for the first time, for the explanation, I just write variable every time. But when I write the code, just I write only for the one variable, and under this variable I put all of function. So I will show you this how we can write the code. So for that I simply suppose simply comment all of line, simply select and then control forward slash at the same time. So now all of line will be commenting. So now it will be not work. Okay. So now I just take the one variable. Suppose I put the variable name is the L8. Okay. And under this L8 variable, I put all of my function. Suppose first function, I just simply write in here, suppose filter bounds function. Filter bounds function with my study area. Suppose I need the image for the BD for Bangladesh. I already mentioned in here. And then further, I just put here the filter metadata. Okay, so in this case, I don't take any new variable. I just only for the one variable, L8, and put at the image properties, suppose cloud cover, and further put at that less than, and set the value, suppose 1. Okay, just put at the 1. And further, I take the another, suppose filter date, and I put this time period, suppose year of 2023, suppose 1st January from year of 2023, December 31. Okay. So now, please.
Sorry, how did you do that thing where you put the / in front of everything?
Yeah. So simply select your code and press Control and /.
Control /. Ah, cool. Thank you.
Yeah. Forward this sign. You can easily get it in the keyword. This sign. Okay. Control and this sign. Simply press. Then all of code at the same time will be commented. So now it will be not work. Just like a comment. Okay. So now I simply put out the filter bounds, filter metadata, and filter date. So in this case, I filtering my image collection using only for the one variable. Okay. And if you want, you can write this type of code. Suppose the spaces doesn't matter for the JavaScript programming. You can write the code in here. Also write the same line. Also there is no problem. Because spaces doesn't matter for the JavaScript programming. But when you write the code in the Python is also sensitive for the spacing. Okay, but in the JavaScript, we can write the code anywhere. There is no problem. It also works. If you can any space or anything, there is no problem. So now further, I want to check. Suppose how many images is available. Just click to the run. So now it show the result, number computing. After filtering, how much images you can got. 71 images we find out from here. Okay. So we find out that after filtering our study area using the filter bounds function, then filter metadata function and filter date function, we find out the 71 images. Okay. So this is my 71 images. If you want to check the all of images information, mainly acquisition time, simply print the L8. So now it show you that all of images date. Okay, we can easily get it all of date. From here, suppose you want to use the single tiles, so simply copy the ID and then you can easily get the single tiles. But in this case, I want to make the composite for whole country boundary of Bangladesh. So for that, I just create the median composite. Okay, suppose for that I simply use the function dot median. Okay, and then further this median I want to clip with my study area, which is BD. In this case, here you can see if I run the code, I can got an error. So it show that L8 size is not a function. Okay, it means that when I use the median function, then this L8 is not a collection. So it convert into a single image, single median composite image. Okay, when I apply the median function. Okay, so you always remember that size function only work for collection. Okay, size function only work for the collection. But when I put the median, then all of 71 images create the single composite. That's why it show the size is not a function. If I commenting, suppose simply commenting this line of code, click to the run. So now it will also work because without median, this L8 is a collection, 71 images collection. But when I apply the median, then it's not a collection. It's just a single median composite image. Okay, so that's why size function is not work because size function only work for the collection, not work for the image. So now I simply create this single composite median images. So that's why size function is not work because I apply the median. Then this L8 is stored at the single images. So now I print only for the L8. So now I can check about that. It show about the image. Okay, not the image collection. Show the image. And this image have total 19 bands. We can get all of band in these images. SRB1, SRB2, all of band. We can easily get it from here. Okay, and further I want to display this image just same as map dot add layer and call the LA. So now click to run. So now you can easily create the composite for whole country boundary of Bangladesh. Okay, we can easily get it. So now
I have
further,
question.
you can, yeah, please.
If I after I write map that add layer, then in console there is a message like not found, does not exist, or caller does not have access. What that means?
Okay, which one? You send me this code.
After I write this exactly this code map that add layer,
Yeah.
there is a message that not found and does not exist, or a caller does not have access. So what's the problem here?
Okay, so image load. Okay. Okay, you okay?
I write it in the chat.
Okay. So let me show. Let me check that. Just a minute. Yeah. Okay, so it show about that land. Okay, you can see about that. It is a Landsat, LAND set. Okay. Okay. And it's a single ID. Okay, so this single ID is only available for the Dhaka city boundary. Okay. Suppose when I import this imagery, I can only find for my Dhaka city boundary. When I use this ID, suppose here I can see this ID. When I write the right, you can see this ID is only available for the Dhaka city study area. Okay, the Landsat this ID is only available for my study area. So further you can easily get it. Suppose just I will send okay, just I copy a code and send you. So simply copy. Okay. And you also try to add the right spelling for the Landsat. Then I hope it also work. And you also need to import your shape file. Okay, click with your shape file.
I missed
Yeah. So that's why it not work.
Thank you very much.
Okay. So now we can easily get it. This type of man composite, and further from here we can easily visualize our visualization for the different types of band. Okay, I hope we can do it for the visualization of the band. So now this image, suppose I want to show for the other study area. Suppose I want to just simply import my study area. Or if you want also take the study area from here. Suppose, so I take this shape file FAO. Okay, you already discussed this data set, because this data set provide you that secondary level administrative unit. I simply import it, and further I simply put my specific cities boundary or other things, simply cities. So further just I filtering. Suppose just take a variable. Suppose just insert that RY. This table I want to filter, and further I choose the specific cities. So EE dot filter dot equal. So what's equal what? We can easily get this information from here. So we can easily get that at administrative level 2 from the table schema. Suppose I want to use this shape file from here. So simply copy this admin2 name is the string. Simply copy and then paste here, and I put the name. Suppose I need this image for Dhaka. Okay, Dhaka. So now I loaded for the Dhaka, and now I simply change the variable name. Suppose BD, I want to need this result for ROI. ROI is stored at the Dhaka boundary. So just put here that ROI, and also click with the ROI. So click to run. So now you can got this result year of 2023. All of median composite create this Dhaka cities boundaries composite. It created. Okay, but in this time it is a single image, and this single image is generate from the all of images which is less than 1 in year of 2023, all of images considered in here, and create this composite. So suppose I just put the another, suppose put here that select, click the one. So now we can easily get that select boundary. So it shows the invalid GeoJSON. I think some networking issue. So let me run the code again. And I just want to focus the center of this boundary shapefile. Map.center object. Object is RY. Suppose put it at the 8.1. So now we can easily get this imagery for this study area. It looks as the black color because I don't set any kind of band combination. So you can simply choose the band combination from here. Suppose red, then put at that green and blue. Custom stress in 98%. So now we can easily visualize this natural color for this study area. So it looks like that. So further, I can easily use this satellite imagery and make for any kinds of map. For okay, suppose I need this result for other districts. Suppose I need for Ranchi. Click the Ranchi. Click run. So now we can get this Ranchi imagery for year of 2023. All of images create this composite. It look like that. Simply can simply click on here and set the band combination. Suppose red and green and blue. Stressing 98%. And further apply. So now we can got this type of satellite imagery from here. Okay? So now we can easily work for that. For any boundary, we can easily get it. But when you want to work for the single date imagery, because single date imagery is depend on the ID, okay? And all study area ID is the different. Suppose for the Dhaka city, which ID I got, suppose you can see this ID is only work for my Dhaka city boundary. Okay, this imagery I can find out only for my own study area. Suppose when I filtering, I collect this ID for single date ID. So that's why it's only work for my Dhaka city boundary. But when I create the median composite, all of images which are available in 2023, then it easily works. Suppose now in this case, it find out all of less than 1% image for this imagery in year of 2023 and create this composite, median composite. We can easily get it. Okay? Suppose I want to show the visualization, red, green, and blue. It's taken at 8%. And then apply. Okay, so now you can easily get this type of satellite imagery. And further, we can also export this type of satellite imagery and also work with that. And from here, we can easily get this update image. You can see what is the last time period. Year of 2024, 0820. Okay, so this is the last update time. Today is the 24. Okay, so it also updating daily. From here, we can easily get that daily imagery from here. It's updating daily. So just I want to check for that last time. Put here. And I have to put here up 2024 08, suppose 20 days. I have to check how much image is available or not for this time. So in this case, you can see for this time there is no image. It shows the 0 bands. It means that less than 1% image is not available for this study area between this time period. So let me check. Suppose I put here that 50% and then try to check what happened. Is it available or not? Also, it's not available. Okay, so suppose let me check for 90%. Also, it's not available. So for that, I need to increase the time duration. Suppose I put the 1%, I simply increase for 7 to 8. And now check what happened. It also not available. You can see. or I put at that 5 to 8. Also not available. Suppose put at the 90%. Okay, so now we can got it. But this imagery have the lot of cloud. Okay, you can see. And now we got it, but it's the lot of cloud we can find out. Suppose let me put here 7 to 8. Also check. It also available. Okay, if I put at the 8, then there is no image, I hope. Yeah, no. So we have to put at that 7. So this time too we can find out this type of cloud imagery because I increase the cloud level. So now for that part happen, we can do. Suppose I need this, but in Google Earth Engine platform, we can easily remove this type of cloud. So if I add the visualization red, then put at that green, and put at the blue, and then stress in 98%, and apply. Okay. So it shows that the very cloudy image we can get it from here. Okay. But in Google Earth Engine platform, we can easily remove this type of cloud and get the very neat and clean imagery. So for the next session, we also, I think it also cover in our, okay, let me check the syllabus. Okay, in the 4th number class, we discuss about that how we can remove the cloud and haze. Okay. Suppose definitely when you want to increase the cloud level 90% or 50% or 10% or 20%, then we get this type of cloudy pixel or white color cloud, we can get it. But in Google Earth Engine platform, we can easily remove this type of cloudy pixel and get the very neat and clean imagery. Okay. So further, next class I will discuss about 4th number class.
I have one question.
Yeah, please. These
we can remove the cloud if we are interested in, for example, use land cover, but it cannot be good for land surface temperature or, for example, the NDVI, because the clouds, it will not give us the accurate result for the land surface temperature.
Yeah. Yes, so for that, when you want to make the land use land cover mapping or also mapping for the LST monitoring, then we need to must remove the cloud and haze and try to use the low cloud cover level. Okay, but sometime, some condition, suppose in this case, I just need for the 1 month, I take the only, I need to find out for 1 month, less than 1% image is available or not. So that's this region I don't find. So that's why when I increase the cloud level, we find out that there are a lot of cloudy pixel. But in this case here you can see, when I use the whole year, from the whole year, I find out that less than 1% image is lot of less than 1% image is available. So that's why I can easily apply the median and then I can easily get this more better imagery when I increase the time duration. Okay.
I have a similar question. So just in the same way that if there's cloud, like the land surface temperature might be not as accurate. If you were to do like an analysis on NDVI or even maybe a land cover classification using a composite, would there be a problem or would there be drawbacks to that compared to just using one scene or a cloud-free scene?
Okay, so further we also need to remove the cloud. Okay, so when you find out the cloud, Google Earth Engine, we can easily remove this type of cloudy pixel. Okay, and then we can easily use this image for making the NDVI map or land use land cover map or other types of work. Okay, so
right. But then when you use the composite for the NDVIs, for example, is there any inaccuracies that are introduced that might be a problem at like an academic level or so?
Yes, so if you don't remove the cloud, then it also affected in your LST map. Sometimes we find out the negative degree Celsius. Suppose for this study area in Bangladesh, is not possible to get this negative, is not possible. But when you don't remove the cloud, then cloud temperature is also including in your map. So that's why definitely we can get that wrong result for LST. Okay, that's why we need to remove this type of cloud. Okay, so when I talk about the removing the cloud, I hope we can easily get this idea how it will work. Okay.
Sir, may I ask one more thing?
Yeah, please.
Sir, simply let us know if there is any method to remove the cloud cover.
Okay, so for that we use the cloud marks band function. Okay, in Google Earth Engine platform, we can easily get the cloud marks band function. So this is the band. We have to use this band, and further we try to remove the cloud. So QA pixel. Okay, so this is that pixel quality attribute generated from CFMAX algorithm. So this band we are use, and further we try to remove the cloud shadow, or cloud confidence. So these type of things, or Cirrus cloud. So these type of things we can easily remove when I use the QA pixel. Okay. So further, for number class, I can discuss about that one by one. You can easily get this idea how it works. Yeah,
Sir,
please.
one more thing, like has also we can remove through this.
This one.
Can we remove has from this the method you are showing to us?
Yeah, I will show you the method. No problem. For number class, we did discuss about that. Okay, it's our 4th number day. We try to discuss about that. Okay, so now we talk about that. Okay, so now this type of imagery, after creating the composite, we can easily export from here. We can easily export the all of band, and further we can also work with ArcMap or QGIS software. But before that, I also discuss about the another data set, then talk about the exporting. So here you can see I will talk about the MODIS. So you also try for the Landsat 9, Landsat 7, Landsat 4, Landsat 5. So this type of imagery you also try to filter for your own study area. And if there's any problem, then also try to discuss about that. So now we talk about the MODIS. So basically MODIS, we can easily get different types of ready-made data set. It can be daily, it can be monthly or 8-day interval. So different types of data, we can easily get it from here. So it provides a lot of data set. And when you filtering this type of data, we are just applying the same process. Okay. For all of data have the same process when you filtering and visualizing and creating this map. Okay, suppose let me show you the one example. Suppose I want to use this data. Suppose I want to use this data. Vegetation indices 60-day global 250 meter resolution. So this is one kind of MODIS data set. It's the 16-day interval, and this resolution is the 250 meter. And this data set provide you the two product. One is that NDVI, normalized difference vegetation index. Another is that EVI, mainly enhanced vegetation index, that minimize the canopy background and variation. Okay, so that's, you can also see about that this MODIS EVI and NDVI product is the atmospherically corrected. Okay, atmospherically corrected, and all of unnecessary pixel such as water, then cloud, then heavy aerosol and cloud shadow is already masked. So that's why when you use this data, then this type of cloud or water pixel or heavy aerosol pixel or cloud shadow is not affected on your NDVI map, or vegetation map is not affected. It already masked, all of things already masked. So that's why when you want to use this data, we can easily get it. We don't need to think about that cloud remove function. Don't need to think about the cloud shadow or water or heavy aerosol, because this data set is already masked all of unnecessary pixel. So I want to use this data. Just click on here. So now we can got all of information for this data. Basically, this is the MODIS vegetation indices 60-day global 250 meter resolution. Pixel area is the 250 meter. And this is the data set availability time. We can get this data 2000 from 2024 07/27, this time period. And this data set provided is that. And you can see we can also get the unique ID about this data set. So every data set, it can be Landsat, Sentinel, MODIS, every data set, we get this type of unique snippet or unique data set. Okay. So now I want to import this data set in my code editor. So let me open a new code editor.
And sir, and for LST, And for LST, is there any such method? Already corrected image.
Yeah, I will show you that just a minute. Okay, I will show you that just a minute. Yeah. So just in this time, we just use the modis. But actually, modis all of product is the correctly all of unnecessary pixel is already removed. We can also find out the modis LST or modis evapotranspiration, modis daily snow cover. So it provides a lot of data set. Okay, so you also try to check it. It also available for the modis also. So now I want to use this data, and further I want to make this suppose NDVI map. So here you can see we can get that NDVI and EVI, normalized difference vegetation index and enhanced vegetation index. So first of all, this data set I want to import in my code editor. So simply copy this snippet ID and then paste here. Then give a name, variable name. So you can put any name as a variable. I put the name suppose data set. Okay. So this is my image collection, and this image collection have a two band. You can see about the band name NDVI and EVI. I want to work for suppose NDVI. So simply copy this band name NDVI and then use here the select function. Put here the dot select and put here this NDVI. Okay. So this image collection have a two band. From the two band, I just select for my requirement band, suppose NDVI. In this case, I choose. And further, this data set is available from year of 2000 to 2024. But I want to need this data for a specific year or a specific month or any specific time. For that, simply use the filter date function and put your start date and end date. So in this case, I put this time, suppose year of 2023, 1st January from year of 2023, December 31. Okay. So now what happened? So in this case, I simply import my image collection. From this image collection, select my specific band, which I need, and also put my time period, year of 2023. So now let's try to check how much images are available for in this data set as a collection, how much image is available in this collection. So use the size function and click the run. So now it's computing how much image. We find out the 23 images for 1 year because it's a 16-day interval. Okay, 16 into 23, almost 1 year. 16 into 23, we can get the 368. So it almost covered the 1 year. Because it's a 16-day global, we can find out the interval 16-day in this data set. So now I want to make this NDVI map, suppose for the whole world. Simply use a map.add layer and call this data set. Click to run. So now it added this NDVI map for the whole world, year of 2023. We can easily get it as a gray scale color. So it shows the gray scale color for the whole world NDVI map, year of 2023. So now I want to add the color. So for the color, they are already provide some color code. Here you can see they are already provide some color code. So just I simply copy from here, copy this color code and then paste in my code editor. So just simply paste here. In this color code, basically they are make a dictionary using the curly bracket. Put the mean NDVI value, max NDVI value. Also put the plated different types of color code. Okay. I simply copy this variable name of color code and paste after the object name. Paste after the object name. Click run. So now you can easily get this whole world NDVI map year of 2023. So you find out this type of NDVI map for the whole world. Okay. So now it's visualized for the whole world NDVI map year of 2023. From where you can easily identify where is the dense vegetation, where is the low vegetation, where is there is no vegetation. We can easily find out that from this map. Okay. But I want to create this NDVI map not for the whole world. I need this map for a specific boundary. So for that, I simply import my own shapefile. Suppose I simply call the US dataset. It provides the international boundary polygon. I simply call and choose my specific country from this dataset. Just take a variable suppose ROI. Call this table. This table I want to filter earth engine dot filter dot equal how I what's equal what. I put the country NA and put here this suppose Bangladesh. So now I want to need this map for Bangladesh. Okay, so it show for the whole world. But when I clip, suppose in this case, I simply clip with my ROI, clip with ROI. Now it show a problem. So here you can see it show this type of problem. This problem is that image collection dot select and clip is not a function. Okay, clip is not a function. Okay, so now what is the solution about that? Clip is only work for image. Okay, so you always remember that clip function only work for image. But in this case, this data set is not a image. It's just a image collection. In this collection, total 23 images are available. Okay, but when I apply this dot clip with my study area of ROI, so that's why it show the problem. Clip is not a function because clip function is only work for the image, not image collection. Clip function is only for the image. So that's why this collection, anyhow, I need to create the image. Okay, so it's total 23 image collection. This collection of the total 23 image collection. So now using the total 23 image collection, I need to create the image. So there's a lot of way we can easily do it. If you want, you can make the average. Suppose you can create the average NDVI map using total 23 images. Then it create the single average NDVI map. And this average NDVI map is generated from total 23 images. Okay. If you want, you can also calculate maximum NDVI map. It also possible. If you want, you can also calculate the minimum NDVI map. Okay. So now I have total 23 images. And I want to clip with my study area of ROI, but clip function is not work for the image collection. That's why I need to create the single image. In this case, if you want, you can create the average NDVI. If you want, you can create the maximum NDVI. If you want, you can calculate the minimum NDVI. So that's why I simply use the function dot min. Now what happened? This min function calculated the average pixel from all of images and create the single average NDVI map for my study area. So now let's check the result. And also you can see in this case, when I apply the mean, then this size function is not work because size function is only work for the collection. So previous code I already discussed about that. Size function is only work for the collection. So that's why I simply commenting this code and click on again. So now it only worked for my study area, Bangladesh. We can get this result for Bangladesh boundary. So now it's about this NDVI map year of 2023, but it's a average NDVI map for year of 2023. We find out. Okay, not only for this country, any country. Suppose I simply search there. Search there. Pakistan. So now click to run. Now it's loaded for average NDVI map for the Pakistan year of 2023, but not focusing. I want to focus. Just use here map dot center object. Object is ROI. Put the 10 and click run. So now we can easily get this map of NDVI map for Pakistan year of 2023. It's the average NDVI map. If you want, you can also calculate the maximum or minimum NDVI also. So you can see you can get this type of NDVI map. Further, suppose I want to check for
can be more than one country.
Yeah, please.
Can you add Saudi Arabia with Qatar and United Arab Emirates and Oman in one, for example, one line?
Mainly you want to make the merge. Suppose suppose you can see the United Arab Emirates or Oman or also Yemen. So all of things you just create the one layer. Is it?
Yes. Yeah,
Okay.
that's what I'm asking.
Okay. So for that, first of all, we have to create the shapefile. Suppose in this case, this ROI is only stored for the Saudi Arabia, but I want to merge. So for that, I take another. Suppose I put this ROI. That was ROI 1. I call the table same. Suppose filter art engine dot filter dot equal, and then put here that suppose country NA, and I put here this country name, suppose Oman. Okay, suppose I take this another, suppose for ROI, suppose 2, same process, suppose table dot filter art engine dot filter dot equal, call the country NA, and put here, suppose I put this name of country, suppose Yemen. And then finally, suppose I take the another, suppose RY 3, call the table, then call the filter, same code, right? EE dot filter equal country NA, and put here this United Arab. Okay, just simply write, or if you have also more countries, simply write it the one by one. So for that, just take a variable. Suppose I put the variable is the AOI, and then this AOI I want to merge. Suppose ROI it merge with ROI 1, then merge with ROI 2, then merge with ROI 3. Okay, so now ROI 1, ROI 2, ROI, then ROI 1, ROI 2, ROI 3. So all of those things is stored in the AOI. Okay, I want to make this final map using the AOI. So just click with AOI. Okay, so now let's check the result. Okay, so now I can get this result including all of country. Okay, which I put in here. We can get this result. For that, if you want to write the Kuwait, then we can easily also consider about the Kuwait. Okay, suppose just take the another variable, suppose third ROI 4, call the table is filter, and then put here art engine dot filter dot equal, and then put here the country NA. I also consider about that, suppose Kuwait, and finally put here that dot merge with ROI 4. So now we can get also consider about the Kuwait, and we can easily get this result. So any country you can simply merge. So basically this process is called the merge the shapefile. Okay, suppose you have some boundary, so now you can easily merge using the shapefile, and further you can easily export this type of map and also work with the ArcMap software. Okay, so this is the map we can easily generate, but this map have a problem. This problem is that if I simply click on the inspector tab and click on this map, here you can see you can get this type of result. It shows the 3784. It shows the result. but we already know about that NDVI values range, NDVI value range always +1 to -1. Okay, +1 is indicating the high or dense vegetation, -1 is indicating about that water body. Okay, so you can also read this article, then you can easily get the more better idea NDVI how it will work. So you can see NDVI values range from +1 to -1, and areas of barren rock, sand, snow usually show very low NDVI values. For example, 0.1 or less. Sparse vegetation such as shrub or grassland or sensing crop may result moderate NDVI values 0 to 0.5, and high NDVI values 0.6 to 0.9 is the dense vegetation. Okay, 0.9. But in this case, if I check the value of NDVI, it show this type of value, okay, which is not reprojected. It show the 3276. We can get this type of result. Okay, so now how I can reproject it, this type of things. So for reprojected this type of scale value, we have to use this scale. So here you can see in this data set they are already provide some scale. So here you can see we can easily get it, this type of scale 0.001. We can easily get this type of